Hey everyone, today we're going to talk about word problems involving the normal probability distribution. So we've had a lot of applications on how we've been using the normal probability distribution. Take note that the normal probability distribution is widely used in interpreting a normal distribution data. The probability that a random person may obtain a particular score can be determined using the area under the normal curve, while the percentage of the population with a particular set of scores can also be obtained using the areas under the normal curve. And we've learned last time that we can determine the particular position of the score of a of a score with respect to its population using the percentages. So now we are going to apply this in a scenario. So let's have this example here. In a given exam, the mean is 23.75 and the standard deviation is 8.31. So here's our situation here. The mean is 23.75 and the standard deviation is 8.31. So we have three questions here. The first one, letter A, what is the percentage of students that got a score of less than 25? So let's illustrate it first. Let's illustrate the problem first. First of all, we have the mean here. The mean is 23.75. And that is the middle score because it's the mean. And we have standard deviations, 3 standard deviations below the mean and 3 standard deviations above the mean. So we are looking at the score of a percentage of students who got a score of less than 25. Let's say that 25 is right here. We're not actually sure if it's 1 standard deviation below the mean, but we're just illustrating it right here. So we'd like to know what is the percentage of students who got a score of less than that. So we're looking at the area, this area here, before 25. So we can use that areas under the normal curve here. So we're going to use a table of areas. But before that, we have to know first what does 25 correspond as a z-score. So we convert first the 25 as a z-score. So we are going to use the formula z is equal to the score minus the mean divided by the standard deviation. So this is actually equal to 25 minus, that is 23.75, that's the mean, divided by the standard deviation, which is 8.31. So let's determine what is the z-score of 25. So let's use our calculator here. So that is 25 minus 23.75. It's 1.25 divided by 8.31. That is 0.15 something something. So let's round it off as 0.15. And take note that 0.15 only corresponds from, the 0.15 rather corresponds to the score 25. So we are going to get the area using the area under the normal curve. So remember that this table is available in Appendix A at the back side of your book. So, and also remember that the area corresponds only from the score towards the mean. So that area that we're going to get there only corresponds to this red area here. So let's look at 0.15, 0.15. So this one, 0.0596. Therefore, the area is 0.0, what was that? 596, 0.0596. There. And we have this blue one here. Remember that in the scores before the mean is 50%. So the area before this 23.75 here, this is actually 0.5 or 50% of the data. So we are just going to add this 2. That would be 0.5 plus 0.05. 0.0596, and this is equal to 0.5596, or 55.96%. So this means that the percentage of students that got a score of less than 25 is 55.96% of the population. So actually more than half of that. So that's how we apply the areas in solving word problems. Let's have another example. So this time, what is the percentage of students who got a score of 30? Remember that the mean is 23.75 and the standard deviation is 8.31. So 23.75 is right here, and we're looking at the percentage of students who got a score of more than 30. Let's say that 30 is right here. So we are looking at the area more than 30. So this is the area that we are looking for. So we have to determine this area here. Remember, this entire half here, let me label it with this orange here. This entire half here is 0.5. It's 50% of the data, and in order for us to determine this particular area here, we have to know first the area that I'm going to shade with the red. This area here, because this is the area that's available to us in the table of errors under the normal curve. It's only from the score towards the mean. So from here, if we obtain this, we can subtract it with 0.5 and we're left with the blue one. You get that? But first, let's convert 30 into a z-score. So let's convert that. Remember, z is equal to score minus mean divided by the standard deviation, which is equal to 30 minus 23.75 divided by 8.31. 8.31, and this is equal to, where's the calculator? There. 30 minus 23.75, that's 6.25 divided by 8.31. So it's 0. There's a lot of numbers there. 0.75210, or just simply 0.75. So this 30 here corresponds to 0.75. Let's look at that one in the table of areas under the normal curve. So this is 0.75. This one 0.2734. So this means that the red area is 0.2, sorry, that was 2734, 0.2734. So in order for us to get the blue one, what we have to do is we subtract it with 0.5. Remember that this entire left side here is 0.5, and this red one is 0.2734. What we'd like to get is the blue one, so we are going to subtract it. So this is going to be 0.5 minus 0.2734. So this is going to be equal to, let's have our calculator here, 0.5 minus 0.2734. That is 0.2266. So this actually this is equal to 22.66% of the scores. So this means that the percentage of students who got a score of more than 30 is only 22.66% of the entire population. So that's how we go around with the percentage is actually less than 25%, less than 1/4 of the students who got this particular score of more than 30. Let's have the third one here. What is the probability that a randomly selected student will have a score between 20 to 30? So let's determine also the percentage so that we would know the probability. Since we're looking at the score between 20 to 30, so let's label it here. This is 20 and this is 30. So we are going to obtain here two different areas. This one area here, and label it here. Let's have the red one here. This area, the red one, and the orange one. This area here. And this can easily be obtained using the table of errors under the normal curve, since the table of errors under the normal curve corresponds to the area going towards the mean. So we just have to obtain that. What we just have to do first is to convert the scores into z-scores. So this is 30, z is equal to, change the color, this should be z is equal to 30 minus 23.75 divided by 8.31. This is for 30, huh? So the z is equal to 30 minus 23.75, 8.25 divided by 8.31. So this is 0.75. So that's the z-score. While for 20, it should be z is equal to 20 minus 23.75 divided by 8.31. So this would be equal to, clear this out, 20 minus 23.75. 20 minus 23.75, negative 3.75 divided by 8.31. This is negative 0.45. Negative 0.45. So we have to obtain the area that corresponds to 0.75 and negative 0.45. So let's start first with the red one. So let's look at 0.75 on our table. 0.75, it's here. 0.2734. Actually, we had this earlier. So this red area here is 0.2734. This is our area. And for the second one, we have 20, which is negative 0.45. So we'll just simply use 0.45. So let's have this one here, what was that? I forgot. That was negative 0.45. So this is 0.45. So right here, that is 0.1734. 36. 1736. So let's label it right here. This is the orange one. 0. What was it again? 1736. 1736. So what we're going to do after this is we're going to add these two areas. So therefore 0.2734 plus 0.1736, and this is equal to plus 0.447. 0.447. Therefore, the area between these two is 0.447. Or if we convert this into percentage, this is equal to 44 40.70%. So this means that the probability that a randomly selected student will have a score between 20 to 30 is actually 44.70%. So that's the probability that we have. So that's how we apply the normal distribution. If you can observe, the application is mostly used in research. So I hope you guys learned a lot in solving word problem involving normal curve. I hope you guys learned a lot today. Thank you guys for watching, and in our next video, we're going to talk about the sampling distribution of the sample mean. So thank you guys for watching. See you guys in the next video.